Good morning, everyone. Thanks for attending today's training session. There is a little mistake with the heading. It's actually grid tie commercial and industry training today. We'll give it about another 5 minutes and then we'll start. All right, let's start. Thanks for joining today's commercial and industry training session. Our training has progressed to be more of an interactive training. So if anybody has questions, please unmute yourself and ask straight away. We can jump straight to answering that question because everybody is already well versed in commercial and industry grid tie solutions. So I believe everybody has quite a good background. If there are any questions or some uncertainty about something, then please ask that question and we can jump straight to it and answer that question. All right. So a very handy site to go to for Sungrow is the Sungrow Resource Center. You just have to type in Sungrow Resource Center. It'll bring in your browser. It'll bring up this website. And it's a very handy website to go to because Sungrow continuously updates their user manuals. And to get all the user manuals or videos, you can go directly to this link, and it will give all the information that you need. So all you need to do is just add in. So for instance, we got the SG110 CX. And it should bring up all the documentation for that type of inverter, along with all the training manuals. So we have the CX. That's not the right one. Sungrow's new inverters is the P2 range. Okay. So here we see the Sungrow 125, 110. The 75 CX is not in the country, but the new P2 range. So for all documentation, you can just go here. And here we see, yes, the user manuals, there's installation videos, quick installation guide, and some other documentation if you need to study a little bit further, but usually supplying the customer with the user manual or even this link that they can go and download that themselves. Alternatively, you can also go to YouTube. YouTube, we have loaded all of the Sungrow videos. For now, it is on Cape Doctor Technical Solar. It's my channel here just to upload all the videos so we can also share the links, whether it be by WhatsApp or email, a lot easier. So everything is already downloaded here. You'll go to the playlists, and under the playlist you can see there is Commercial and Industry Grid Tie, and then there's also the 6RS, the hybrid inverter. All the videos that have been downloaded there. So if we just go into the playlist, for instance, we can see there's the SG110 installation video. There is the Acral meter settings, both for the CT settings and also for the communication address setup. There's the IM4 logger firmware download methods. There is the logger 1000 login, which is 2 options that you can log into. There's the logger 1000 commissioning, how to do the whitelisting of the firewalls and the Internet of Things. Those need to be whitelisted, and then there are also ports that also need to sometimes be whitelisted from the firewall if there is communication issues. And then there is the logger 1000 setup wizard video. So all of these are free, well, easily accessible. You just have to type in Cape Doctor. It might bring up my other YouTube channel. You're free to subscribe there too, but this one is the Cape Doctor Technical Solar. So those videos are available for download, but we will start with this presentation. Okay, so On all the other, the previous models of the CX inverter, the IM4 dongle was used. This IM4 dongle could have connected up to 10 inverters. With the new P2 range, you can only connect one inverter to the IM4 dongle. For multiple inverters, you will need to use the Logger 1000. So with the all inverters that don't have P2 behind it, this is applicable. That you can connect up to 10 inverters in a daisy chain just using this dongle. But now with the new C2 inverters, only one inverter can be connected to this device. So previously we were able to connect up to 10 inverters onto the IM4 dongle. And the Krell meter connected to the P2 to the A2B2 port of the inverter. With the new P2 ones, it's the A3B3 of the inverter for the meter. If you require extra channels in the Logger 1000. Okay. So with the previous versions of the inverter, we required that they was a certain method for connecting in your daisy chain. You could either use the RJ45 plugs in and out method as indicated here, or you could use the 2-wire with or without the sheathing being earthed on one side only. But the method was to follow the in-out, in-out, in-out on all the inverters on the A1, B1 Modbus connection plug. Okay, so looking at it a little more in depth, over here your RS485 for connecting up the inverters in a daisy chain, you would use the A1, B1 out and A1, B1 in for connecting up all your inverters. With the Logger 1000, you could connect up to 29 devices. So that could be 29 inverters or 28 inverters plus a meter, or 27 inverters plus a meter plus meteor sensors. This A2B2 we would use in the event we needed more channels, and we could put the meter over here, and what we'd need to do was just go and action the transparent transmission inside the inverter when we connect to it locally. We'll get to that now. Now with the new P2 inverters, it's no longer the A2B2 for the meter, it's now A3B3 for the meter. This is available in the user manual of the inverter. Okay, here we see the RJ45 plugs that could also have been used for the daisy chaining of the inverter if you had those cables already made up and would prefer to use that. And then we have the 120 ohm resistor switch, which is more for if you have more than 7 inverters in a daisy chain. It helps to stabilize the RS485 communication, so that the RS485 communication knows where the string starts and where the string ends. So on the first inverter, you'll action the 120 ohm resistors, and on the last one, you'd also action the 120 ohm resistors. Okay. So for this A2B2 to work, this auxiliary RS485 connection, one would have to go into the inverter and action the transparent transmission. So you'd follow this diagram to transparent transmission, which is the standby RS485 port, and you'd action this on. If you didn't action this on, your meter wouldn't be able to work. So part of that commissioning would be to action that auxiliary port for the RS485, and then the meter would work. Okay, so there's a number of ways to connect to the device. The most common way would be with the the Wi-Fi of the device. So the IM4 and the Logger 1000 are exactly the same. The only difference is that you'll see here right at the top of the tabs, once you get into the remote maintenance or log into the device, it'll either say IM4 here, or it will say Logger 1000. Also on the serial number, the IM4 starts with the A and the Logger 1000 starts with the B. So Sungrow's portals or remote maintenance portals are all the same, right from utility, which will be the Logger 3000. So right from utility all the way down to the IM4, which is the smallest unit. If you have done an IM4, then you'll be able to even understand what the utility system looks like. So they're the same all the way through. I prefer to rather use a laptop. It shows a bit more than the iPhone, but you can do it on your phone as well. I definitely do prefer a laptop or tablets. It just works a lot easier. So the Logger 1000 and COM100E are the same thing. The Logger 1000 is the device found inside the COM100E, and the COM100E is the total casing. You see, it's here. It's not in this presentation. So the COM100E is just the housing with the surge protection, with the power supply, with the breakers, with the internal light, and the housing with the Logger 1000. So often you'll hear people refer to the COM100. But the COM100 is the Logger 1000. It just is the complete unit with everything inside it. All right, so when you connect to the Logger 1000 or the IM4, you will go to your Wi-Fi at the bottom of your laptop, like this, and you will see that it will come up at the bottom of your laptop at your Wi-Fi. You'll see the hotspot of the dongle or of the COM100, and you will log onto that hotspot. You will then open up your browser, and in your browser you will type in the IP address 11.11.11.1. That'll bring up this page. This is connected to the IM4. As I said previously, just here on the top it'll say Logger 1000 or Logger 3000 if you're working on the utility. Once this page comes up, you'll only have limited access. You'll need to log in. You log in here on the top. You can change languages if the language is not right. You log in here. The password is PW1111. Once you log in, then it will open up the rest of the operation and maintenance tabs that would be available. All right, so initially you've connected up your inverter in a daisy chain, you've connected your meter, and now you need to look for the devices. You can automatically search. Under automatically search, the inverters should self-populate already. You'll see here there is a little link. When the link is green, that means that inverters are communicating with the logger. You will then add your meter. In adding your meter, you will go to add device. Under devices, you will select your meter. There are multiple devices here. You could add a huge variety of there is a bigger variety of devices in this drop-down menu, but you will add your meter. You will put it in what COM port it is. So if it is in the inverter, it will be COM1. If it is in the logger, it'll be COM2 probably, or COM3. If it's in the logger, sorry, depending on which RS485 you use. So if you use RS485 A1, B1, that's COM1. If you use RS485 A2, B2, that's COM2. If you use RS485 A3, B3 in the logger, then that'll be COM3. But this one here, we can see this is connected to the inverter in daisy chain, and it is then connected to A1, B1 inside the logger. And so we put here COM1. We can then go to the next drop-down list and select the meter. This is the Acrel meter, DTSD1352. This is the Acrel meter, and the beginning address will be 254 and quantity 1. We can then add that, and the link should be green once it is connected. Okay, so here we see inverter has been connected, SG110CX, and the meter 1352. It's a meter, everything is green, and so we're happy. The logger is communicating with the inverters as well as with the meter. We see here it's in COM1, which I can then say, all right, this meter is connected to the inverter, and it's coming in one of the COM ports of the logger. All right. Okay. We would then have to go to device monitoring. Under device monitoring, you click onto the meter tab, and under the meter tab, you can click on initial parameters. And in the initial parameters, you need to fill in the CT ratio. The CT ratio is the primary divided by the secondary coil, and that gives you that CT ratio, right? Meters are always a gateway meter. 99% of the time, the meter type is going to be a gateway meter. A gateway meter is a meter that is connected at the main incoming of Eskom. The reason for it being connected at the main incoming is because it's the point of reference the inverter uses to understand where does the client's grid start or end, where does Eskom end, and where does Eskom start, and where does the client's load end. So it's very important that that gets installed in the right place so that the inverter can understand to what point it is going to supplement the loads. Anything past that meter is now going to be export. So if we want to control export and set 0 export, we're allowed to supplement power to that point. So the meter is the eyes and the ears of the inverter for it to understand where it's allowed to operate or provide power to. Okay, so that's why we call it a gateway meter. There is another option here as an energy meter, and under energy meter, it is just going to read. So it's very important that we make this a gateway meter. Okay. Are there any questions? Everybody's very quiet. Okay, then I'll carry on. All right, so when we set our 0 export, we'll go here to the active power tab. Under the active power tab, we will scroll down, and here we see time schedules, and we also see fixed in value of active power. It can either be by kilowatts, or we could change the instruction type here from kilowatts to a percentage. But at this point and this setting here, we are actually exporting 50 kilowatts. If we do not want to export, then we make this a negative. I usually make this, or suggest to make this, a negative 10 kilowatts. It can be changed to a higher or lower level depending on how the loads fluctuate. If the loads fluctuate very quickly, then you want to make it quite a lower or also a higher negative. So negative 10 kilowatts, the inverter will always be producing negative 10 kilowatts to the load. If the load does fall away very quickly, then the inverter has time to react. If you fine tune it to -1 and the loads fall away very quickly, you do have a chance that the inverter might not ramp down fast enough, and it could potentially export a little bit of power because that load disappears very, very quickly. So here, this setting here is to export 50 kilowatts, but usually we're not allowed to export, so we'll make this a negative, and the inverter should not export. After that, always remember you must save your settings. Okay. Okay, so when you are setting up your device in your plant, you will need to scan the inverter, you'll need to scan your communication device, and you'll also need to scan your meter. So if we go to a plant, for instance, we're going to go to a plant quick. So this is the isolar cloud. Under the isolar cloud, your client's production values and also all the settings are available here. We'll go to a commercial PV. Okay, so this is the isolar cloud. This is what your plant will look like, or your customer's plant will look like. And they'll have a variety of different inverters or different plants available on their portal. They would be able to go into any one of these devices. So we're going to just choose one here. Okay, so this is maybe not a, yeah, okay, so this is quite a good one. So here we see the client has actually got an extra sensor on here. It's a transparent irradiation sensor. They don't have a meter, so potentially they're allowed to export. So they don't need a meter, and they've chosen to rather use a irradiation device. So this yellow here is the intensity of the sun, and they're able to see what's the intensity of the sun versus the production of the PV. Usually these two lines should match up, but here we can see that the inverter is actually producing more than what the sun should be producing. This could be for a variety of reasons. It could be that the panels are nice and cold. Because they're cold, there's no resistance in the modules, and so they can actually do standard testing condition outputs versus normal operating condition outputs. So normal operating condition output on your modules is going to be a lot lower than the standard testing condition. Standard testing condition is your ultimate. If it is the most perfect conditions, then you'll get a standard testing condition. But your normal operating condition should be a little bit lower than your standard testing condition. Okay, so this is the overview of the page. And here we can also go into month production, for instance, year, or we can just go by dates. So we see, have a look and see what yesterday was like. Okay, so yesterday there was good production. It looked like the sensor had some issues. Normally there should be a bell curve or parabola, but these dips and everything inside here is potentially because of cloud cover, and because we're nearing autumn now, the sun intensity is a little less. And we can see it may have been a bit of load shedding. We take off the transient okay. Also a lot of cloud cover. All right, so we can go into device. So under device, we see all the inverters. We see the communication module, and they've elected to rather put in a meteor station and no meter. Okay, you can click on any one of these devices. So we see here inverter 1. Under general information, we get the AC value overview. We can see the MPPT information overview. Get some additional information on the strings. And then some general information about the inverter. If we click on any one of the sine waves, I want to just select the right one. Okay, so we have a look at phase A voltage, for instance. You can click on the sine wave. It'll bring up all the values for that sine wave. So you see, this was either load shedding or it was just switched off until 5:30, and 5:30 the AC came on, and we can see the values that were reported on that grid on the AC phase A. All right, we can go here by date. So let's do a week. 13th to today. So it seems there was some missing information. We can also go by time. So 15 minutes for the week is going to be the shortest span. Let's have a look. Okay, so there's some missing information. See the total yield. Okay, so it looks like there may have been some issues with the plant. Although 1.2 megawatts is quite a bit. Right, so that was today. So we can go for a week. Let's see how it was over a week. Okay, so this is a new plant. It's only just started. Okay, some companies like the IPPs, they may want to take this data and use this data in their financial modules to bill to the client. They have that option to download this as a CSV file. So up here are the 3 dots. We can change the display. Now it's in an Excel format, and you can save the table as and export it as a CSV or an Excel file. Okay, so that's under general information. Also under general information, or the next tab is active faults. So if you go here to active faults, it'll give you what the real-time fault is. We also have fault history. Fault history is very useful because it can also tell you what the site has endured up to present. So it can give you a bit of a background as to what the faults were. I think this is a new plant, and is there were no faults registered. You can also go to chart for analyzing. You can either go by day, week, month, year, or a custom. And here you can select either to have a look at the total power or DC values. Or we can go to AC values. All right, so here we can see if we scroll over it, we're going to get voltages and amperages of the strings. This also helps us quite a bit in analyzing to make sure that the string voltages are symmetrical. Or we can go into the filter and we can add what we want to have a look at in the filter. Okay, so they're producing about 1.2 megawatts on this plant. Okay, So that's in the actual device. You can monitor any device. If there's any device that does have a fault, then you're able to monitor that here. This is potentially a IPP plant. So they just want to produce as much power as possible. They probably have a bidirectional meter or a 4-quadrant meter on the gateway. So the municipality is probably monitoring, or they're monitoring in on a different platform for what they're producing. It's always in their best interest to have a look at a third-party monitoring device so that they can cross-reference and not always rely just on the Sungrow values. All right, so under the next important one is plant configuration. When you're setting up your plant, this is going to be the first part that you'll enter, and here you'll enter all the correct values. Here you can also add your channel partner, your customer. So if you scroll all the way to the bottom and you need to add your customer at a later stage, here channel partners is where you'll add your customer and you'll add his email address. Please note that you can give your customer either lookup data only. That means that they don't have any access to settings, which is very important that they don't go and play around with the system, or you can give them as an administrator rights, and they will have access to change settings on the system. Remember that the system is NRS, so all of the settings that have been set up as to how the inverter works is already predetermined by the NRS. If you do make any of those changes, you may potentially be setting the inverter outside of the NRS, and that'll make that your inverter now becomes non-compliant. Okay, so here you can add in your client's email address. Remember that your client needs to have a iSolar Cloud account. Usually what would happen here is if you do add him in here, his email address, he'll get prompted by the iSolar Cloud to go and create an account, and that would add him here. Right, and then you just confirm after you've added him and given him whatever rights it is that you think that he's competent for. Okay, also what's quite important is here we have a me. If we click on this me and profile, yeah, we would request that under upper level organizational information, you will add Hudaco, and that is quick support at hudacoenergy.co.za. That would allow your plant to be hosted also on the Hudaco portal. So if there is a issue with your site, that we can evaluate and assist. All right, so jumping back to plant tariff. Okay, settings. Here we have all the inverters that are available for conducting any settings. You'll click on the inverter. This initial grid connection is what you would have already done, and it's the information pulled through when the client creates his plant. So here we see it is all under other 50 hertz. So I'm not too sure what or country this is, but it's a 50 hertz grid. We would go to common parameters. Under common parameters, we have the ability to shut down or boot the inverter. There's protection parameters. Usually for South Africa, NRS protection level is protection level 3. And here we also find the transparent transmission. Under power control, the transparent transmission is the actioning of that RS485A2B2 port. So it can be done here too. We see here that the latest values are all blank. All of them are all blank. Even here, boot shutdown, we don't know if it's running or not. So what we need to do is we need to do an inverter parameter query. I'm not going to do it now because it takes about 5 minutes. So with the inverter parameter query, it will then go to the inverter, ask the inverter for all the information as to how it's running, and it will then populate the latest values here. So when one is doing a settings verification, always do the inverter parameter query. Sometimes you'll see latest values here, but they might not be the real values, because somebody could have changed that value, and without doing a parameter query to update here, these values could be wrong. Right, so that is common parameters. We then have advanced settings. You go to the drop-down list here, go to advanced settings. Under advanced settings, there's also very little that anybody really has to do. Also, we see here the latest values are not populated. So we need to do an inverter parameter query. That'll take about 5 minutes just to draw all those values up. Power control. So essentially, all of these settings will get pre-populated by the NRS requirements. Okay, there are some things that can be quite useful here. For instance, here we see reverse string, so not reverse string alarm, meter, reverse meter. Okay, it's somewhere here. If your meter, you've installed your meter CT the wrong way around, and you see that your values don't make sense, there is a setting here where you can actually reverse your meter. But I can't find it. All right, are there any questions to this point? Okay, jumping back to the presentation with the COM100 and the IM4 for commissioning. It's very important to note that there are some firewall whitelisting that needs to take place. There's APIs that need to be whitelisted, and there are also some ports that also need to be opened for the device to communicate over the client's firewall. So in some cases where we find that there is communication issues, or we cannot pick the system up, the client may need to contact his IT and ask the IT to whitelist and open certain ports for the device to communicate online. Okay. Also, what's pretty useful and important to know is that at the bottom here, we see the Wi-Fi indicator is orange and the cloud indicator is also orange. If these are white, it means that the communication cannot be made. So if they are orange, then we know that the Wi-Fi is working and that there is access to the cloud. Okay. One of the key functions for the COM100, the IM4, is that they have the ability to have their own portal. Their own portal is called the remote maintenance. Remote maintenance is more for the operation and maintenance user to go and draw things like fault lists, get real-time values as to whether, or the product, or real-time values as to what the system is doing. They can also do firmware updates via this plant, and they can control or this portal override all other settings that are done. So we can do settings in the isolar cloud, We can also get data from the iSolar cloud. Mostly the data from the iSolar cloud is going to be about 5 to 10 minutes old, but on the remote maintenance, it's going to give you live data. To action the remote maintenance, you need to ensure that you are using the right server. For South Africa, in fact, for the whole of Africa, we use the international server. There might be a little bit of a issue selecting the international server. So what we would have to do is go to transfer configuration. Under transfer configuration, we might need to add in the .hk behind API isolarcloud.com. If that .hk is not there, then you cannot select international server. So to change this, you go to the gear wheel here, select the gear wheel, and then you just add in behind .com.hk. So it reads like this: api.isolarcloud.com.hk, and HK is a Hong Kong server. So the Hong Kong server is the international server for us. And if that h.hk is not there, then in remote maintenance, which is just above here, you won't be able to select international server. So just a small three little things can prevent you from selecting the international server, and all you need to add in is the .hk under the transparent or transfer configuration. Okay, so remote maintenance, once you have that .hk under transfer configuration, then in remote maintenance, you can then go and action the international server. Once you push save, you'll get a serial number and a password. And from anywhere in the world, if you go to remote maintenance, Sungrow remote maintenance portal, you'll be able to action, or you'll be able to get onto the device from anywhere in the world using your browser. And yeah, you'd be able to override any other settings that might take place. Only one person can get access to the remote maintenance server at any one time. So whoever is on this server will override any other settings conducted on the iSolar cloud. For instance, you could action certain settings on the iSolar cloud, and if you change them here, it would change everywhere from the remote maintenance server. Okay, gonna jump to, so with all new clients, we ask them to please do the cold and the hot commissioning sheet. The cold and hot commissioning sheet sets the client up for being able to do their warranty registration. Sungrow asks for a variety of pictures and information before you can lodge your warranty registration. All systems need to have their warranty registration in place so that they can verify that the installation was done correctly. So if the client goes step by step through this document, it'll help them to set up the device properly. It will also help them to gather all the information that they require for their warranty registration. And it's going to be things like pictures and certain verifications of the inputs that they all write. If you forward this to us, we will also have this in our database, so that at a later point, if the customer comes back to us, we have a point of reference to understand what was their site's installation like, how initial values were, and how some of those input values can change over time. And we don't have to go backwards and forwards all the time asking clients for information that could frustrate them. But obviously we need this information to be able to support them. To give you a little bit of a idea, I'm just going to go to a client here quickly. Client was very, very impressed about his installations. They were very, I'm not going, client was very impressed about his installations, and he was very happy to show us what his installations look like. So if we have a look at this installation here of theirs, this is a 100 kilowatt system using 250 P2s, but we can see here there's no space here for the cable for the trays to come out. So they didn't actually listen or read the user manual properly. They were bragging a little bit more about their installation. And here also, once again, spacing hasn't been, they never read the manual. It's very neat. It looks nice, but here's a service tray. That service tray cannot be accessed. Service tray for the fans needs to come out. So yes, nice installation, but wrong. Here again, nice installation, looks very neat. But here we can see that the inverter is now the bottom inverter is going to be pushing all the heat up to the top inverter. So we're going to get derating on the top inverter and potentially clipping when it's supposed to be cooling itself. It's not cooling, it's taking all the hot air from the bottom inverter up. Also, they got all the switch gears over here, now also preventing adequate airflow going through. All right, so coming back to the document, what's very important, obviously your customer needs to create an iSolar Cloud account. His customer also needs to create an iSolar Cloud account. Usually when he goes into creating his profile or his plant and he adds a channel partner, the customer, once he adds in that email, the customer with that email that was added should get a verification or a prompt on his email to create an iSolar Cloud account, and that will allow him to then get added to his plant. Remember, all plants must be created under the international server. If it's not under the international server, then we have to go back to Sungrow to ask them to take it off. And usually the guys are using a European server, but we're all under international server. Once again, the spacing of the inverter. So it's very important that the customers study the user manual and understand how does the manufacturer want their inverter to be installed so that the warranties can be honored. If the customer doesn't install it as per what the requirement is, then the manufacturer has full rights to say that our product cannot be deployed like that. It can, and we will void that warranty. So in those previous pictures that I showed you, basically those inverters warranties would be voided because they're not installed as per the user manual. You get a lot of customers like that. They think they know everything, and they've probably got huge amounts of experience, but the manufacturer has the right to say how that device is deployed, and they also give clear description as to how it needs to be deployed, and that's based on tests and logic about the longevity of that system. All right, so very important in your cold commissioning, your system is going to be switched off, everything is switched off, and you're going to be testing all of your inputs. If you follow this document step by step, it's going to help you basically 90% to get your system up and running. So it's a very handy document to have, and we send it out to everyone. And all customers should fill this document in. It's only going to help them with their warranty registration, because Sungrow do ask for quite a bit of information on that warranty. All right. Everybody's been very quiet. Is there any questions? Okay, so the documents also got everything that is required for the API on the firewall side, and right at the bottom of the document, after all the pictures that have been gathered for the warranty registration, is the upper level organizational code, where we ask that you please add quick support at hudacoenergy.co.za to please add this to your plant. This will bring your plant up under our portal, and in the event that there's any issues, we can evaluate that plant and do some corrective measures if it is required. So sometimes we might have to increase the ramp up or ramp down rates of the inverter, and we can do that from our plants to ensure that there's zero export on the inverter, for instance, or if there's diesel generator integration. And in diesel generator integration, we might need to action some things like fallback settings. Fallback settings are things like what state the inverter needs to go to in case of communication loss. So if the inverter goes to a communication loss of the meter, then it doesn't know where the grid starts and ends. The inverter might need to go to either the base load power of the load, or it needs to go to zero because it doesn't want to export and you can't really determine what that base load is. Also for diesel generator integration, we might need to increase the ramp up and ramp down rates so that the inverter can react fast enough for the set points set by the diesel generator control. All right, so that's it. If there are any questions, then please feel free to ask. Dean, you're very quiet there. Anyone questions? Sean, getting a little worried there. Okay, let me check.
Ian, can you hear me now?
Yeah, I can hear.
Excellent. Sorry, man, we were all muted.
Well, mute notifications. Is it okay?
Okay, so it seems to be working well now.
Yeah, okay. You fixed it. Whatever you did, you fixed it, Ian.
I didn't do anything.
Yeah, no, it was muted. Sorry about that. I just fixed it in the meeting, Ian.
Okay, thanks, Wade. All right, guys, are there any questions? I got worried there. I thought I was just talking to myself.
The coffee was good. Yeah, Ian, thanks very much. The presentation from on our side was quite technical. We're very excited about the new range of products from Sungrow, specifically the 125CX. I was hoping in one way that the presentation would include a little bit of an overview of the product itself. I mean, in essence, we're salespeople and we appreciate the technical background, and we're thankful for the in-depth presentation on it. If you do have something maybe for 2 to 3 minutes or whatever, just to cover in terms of the product itself, just for those that are maybe not that technically minded or based as such, it would add tremendous value. Or if you're possibly going to do another one in the near future, just on the product overview, we would appreciate that as well. But overall, as I said, was very, very informative. Maybe a bit too technical for some of us, but we at least need to know what the overview or what the product's really capable of doing, which is an amazing product. And as you know, we've got one or two or three running, and we're very, very happy with the range. Thank you.
Thanks, Dean. Okay, so the P2 is a bit smaller actually than the 110. Also, some of the spacings between the old 110 was 800 from the one side because it had a service tray, or it has a service tray. The new ones is about 600. So they've made them a bit smaller now, even though, or they've not combined, they've made them more compact. And there are a few things that I probably would have liked unchanged, like for instance the IM4, which is quite a handy little dongle. That handy little dongle can take up to like 10 inverters, so you can easily do like a 1.25 megawatt plant just based on that one little dongle. But however, Sungrow have now said that there is no reactive power control. So reactive power, so we've got active power, and then we've also got reactive power control. So with the IM4, it doesn't have reactive power control. So now they're pushing towards the COM100E to be used with the device, which in a way is actually quite great, because now we are able to connect a diesel generator integration onto the unit. So previously with the IM4, you had to choose. Either you're going to go with a diesel generator integration, or you can have the COM100, or you can have the IM4, but you couldn't have both. Now that they're moving towards the COM100, and as you know, in our present climate with all the load shedding, it's going to be extremely difficult for any EPC to be able to guarantee a payback time. So when we're looking at our solar products, we want a payback time, and solar is probably one of the only products that actually have a payback time, other than things like maybe your meter on your geyser. The meter on your geyser has a payback time, so that meter will probably cost you maybe 500 Rand. And with you using that meter, it's going to save you some money, and eventually it's going to pay for itself. Your car sometimes has a payback time also, to get to work, to have fun, enjoy. Eventually that also, your car has a payback time. Solar power also has a payback time. Its payback is normally about 3 years on average. And then you're looking at 25 years, or actually 22 years under linear warranty. So the linear warranty on your solar panels is 80% of its original output at the end of year 25, which means that your solar products actually last 30, maybe 40 years. So maybe at year 30, you're only producing 70% of the original power that you had in year one, but essentially it's still paying for itself, or it's still adding value even at year 30. So the linear warranty on solar panels is 25 years. You're looking at 22 years of free energy. But with any grid tie inverter, you need to have a voltage, and you also need to have a frequency reference that is supplied by the grid. So if the grid fails, the inverter switches off. So now we find that a lot of customers are using diesel generator integration, and that could be Elam, Ecombi, Nuvo, or the Wattman. So then you have your inverter running in conjunction with your diesel generator. Diesel generator provides 30 to 40% of the load, and the solar power can then supply 60 to 70% working in conjunction with the diesel generator. The reason why the diesel generator needs to supply 30 to 40% is so that obviously it's working. Those diesel generator motors are designed to work hard. If they don't work hard, then we get a thing called piston glazing. So that's when it's not working, it's running in freewheel, and that's not good for a motor that's been designed to work hard. It's almost like these big caterpillar trucks that pulling loads from one province to another. It's not good for those trucks to run without a load. Other than the truck is running with no cost, a truck always wants to be carrying a load and making money, but other than that, that engine has been designed to carry a load, and when it no longer carries a load, it can damage the engine. So same with the diesel generators, they need to run with the load, and hence you get the piston glazing because it's freewheeling too much. So now with the new COM 100, we're able to put on diesel generator integration, which also saves the customer 60 to 70% on their diesel cost. And at the same time, it also helps to realize that payback of solar. I think that if people were starting to have a look at the financial models on a solar system and include diesel generator or diesel savings, your paybacks could be 1 year. Your paybacks could be on average 2 years just by saving on diesel. So the diesel generator integration, I think, is a very important part of any system nowadays, especially for solar, to realize that payback and also save the customer money in servicing of the generator as well as additional diesel costs. All right, so in that, the new 125P2, we see here that the RS485 for the meter is in A3, A3B3 of the RS485, whereas the previous ones was the A2B2. So that has changed. Also here in the manual, what is quite important, or shall I rather say quite useful, is if you scroll all the way to the bottom. Okay, so that's just the idea. This is for the daisy chaining, the A1 B1. So it's A1 B1 in, A1 B1 out, and that's for the meter. That's changed on the new ones. I just want to go down to the specs quickly. I think what your customers will be asking is, how much can you overload the inverters by? So usually with Sungrow, it's, sorry, let me jump here. So usually with Sungrow, you can overload the inverters. Here we see in the appendix, the technical data. Your customers are going to ask, how much can we actually load onto the inverter? So here we can see with the 125, we can actually put 175 kilowatt peak. That's your PV. 175, so that's 1.5 over. So you can add an extra 50 kilowatts onto this inverter. And why would you want to do that? So the inverter can only produce 125 kilowatts, but you're putting on 175. So in winter, when the sun's irradiation is less than 1 kilowatt per square meter, you're able to still potentially achieve that 125 kilowatts because you've overloaded extra on the DC side. So if you overload that extra on that DC side, the potential of reaching that 125 kilowatts in winter is more of a reality. In the 110 P2, you can add 150 kilowatts onto the DC side, and the 75 we don't have in South Africa. Okay, so still the maximum input is going to be more or less 1,100 volts, but that's you never want to add 1,100 volts onto the input side, because I think by NRS law, 1,000 volts is on all inverters is the maximum that you're allowed to go on the DC side. But if somebody is loading on the open circuit voltage of the string, they are loading 1,000 volts. So remember that we've got standard testing conditions and normal operating conditions. Your EPCs might only be working with normal operating condition inputs, and they will need to, there is a potential under standard testing condition that that module can reach a higher voltage, and that can damage the inverter. So strictly speaking, we want to keep within the sweet spot of the MPPTs. So if we scroll down, we can see that the MPPT voltage range is from 550 volts to 850 volts. So essentially, the customer is going to have their open string voltage more or less around these figures. Even though the MPPT range is 180 volts to 1,000 volts. So that's the happiness of the, well, that's the range of that MPPT, but the happiness or the best place, the sweet spot, is going to be between 550 volts and 850 volts. So in that string design, this is more or less where the customers are going to be designing their open circuit voltage. I think, Dean, is there anything else that maybe I can have a look at for you guys?
If you can maybe just comment just in closing. Thanks very much, Ian, for accommodating us. We do appreciate it. Just comment a little bit about the MPPTs in terms of the number of MPPTs that you have in the current, which is actually quite important.
Okay, so the 125 has got 12 MPPTs. The 110 has got 9 MPPTs. I see they don't have it in here on this. On this, I have highlighted that to Sungrow that they are missing some information here. But the 110 has got 9, and the 125 has got 12 MPPTs. There are 12. Sorry, there's 2 inputs per MPPT. So you're looking at 24 and 18. So 24 on the 125 and 18 on the 110. What's very important is that the whole idea behind a MPPT, an MPPT is designed for, or shall I rather say, the multiple MPPTs is to accommodate for multiple angles on a roof. So if you've got, say, 12 different angles on a roof, then you're going to put your strings according to the MPPT or according to the angles into that MPPT. You want to have the same orientation and the same elevation per string going into an MPPT. Also, you want to have those voltages symmetrical. In other words, there cannot be more than 10 volts difference between those 2 strings going into the MPPT. So that is the function of that MPPT, is to accommodate for multiple angles of strings. If you do have too much of a variation in one MPPT, you're going to be picking up some faults. The inverter has a protection inside it. It's either the AFCI, which is arc fault detection, or it's going to give you a reverse polarity. So the manufacturer takes it for granted that everybody understands this philosophy, that you're going to have same orientation and same elevation modules in one MPPT, and so they provide enough MPPTs so to accommodate for multiple roof alignments. That fault reverse polarity is because of them understanding that everybody potentially must know this information and follow that philosophy. And therefore, if there is too much of a difference in that voltage of the inputs into one MPPT, clearly there must be a fault. So then the inverter will register a reverse polarity, or you could get a AFCI fault, meaning that the inverter is now seeing too much of a difference in those between those two inputs in one MPPT, and therefore there must be some type of a fault. So this is to safeguard our industry, to add extra value in the sense of safety. We don't want solar panels catching alight, burning down people's roofs. So in the interest of safety, they've then made it that there must be some sort of a fault, and that can potentially save a building and also keep our industry safe as it's supposed to be. All right. So coming down, we see that the number of strings per MPPT, that's 2. So that's where I was saying that of those, that one MPPT's got 2 inputs, and those 2 inputs need to be symmetrical in voltage. They also need to be symmetrical in amperage, because you're going to be using the same types of modules on your system. It's going to be very rare that you're going to have different types of modules. And if you do have different types of modules, that's also fine, but you need to keep them the same into an MPPT. So if you have some 500s and some 550 watts modules, you can add that into your total system, and you can connect that all onto the inverter. You just need to keep them on the same MPPT. Otherwise, there's going to be some faults from that inverter. Okay, so the maximum PV input current basically is going to be 360 amps, and that is divided into 30 amps per 30 amps per MPPT, and that'll be 12 of those. So we have a look at most of our modules. Most of our modules are about 11 amps. If you do have a, maybe you're using bifacial modules. Bifacial modules can give you up to 40% increase in your wattage, provided you've painted below the module a reflective surface so that any electrons going through the actual wafers and module gets reflected back onto the underside, hence bifacial. So it's got 2 points to pick up electrons. Those might have something up to 16 amps on the module. So you can connect that to the Sungrow inverter, even though your maximum is 30. What will occur is you will get clipping. So in other words, it will only allow that 30 amps per MPPT. So the maximum is potentially going to be 15 amps per string, which is all right, because if you have a look at the modules on standard testing conditions, is usually 15 at the maximum. Normal operating conditions, you're looking probably 11 amps. Okay, so then also, so this applies for all the inverters, the 30 amp maximum on the MPPTs. Anything higher than that, you must just also remember here we have the 40 amps. This 40 amps is a short circuit current, and that is based on the connector. So your MC4 connector's maximum amperage is going to be 20 amps. It can take 20 amps before it starts to melt. So we're looking at 40 amps maximum that will be able to go onto per MPPT, and that's divided by 2 because your MC4 connector can only support 20 amps. Anything else there, Dean?
No, I think that was great. Thanks very much for that clarity. It was exceptionally well explained, and I'm sure for those that are attending, if they ever questions how to the fundamentals of designing a string and what needs to take into consideration. You've explained it clearly. Thank you very much for that. We do appreciate it. Thanks.
Maybe I could also just open up a document. We've been working on a calculator to also help with the string design. So I'm just going to open up this calculator quickly. So it's still in the working. It's almost finished. Okay, so if we're having a look here, these are the inverters. So we've got the 125, 110, the 50, and the 33. So those are the grid tie inverters that we're supporting. MPPTs, we're looking at 12 in the 125, 9 in the SG110, 5 in the 50 kilowatts, and 3 in the 33 kilowatts. The MPPT range is anything from 180 volts up to 1000 volts for all of the devices, except for the 50, which can do 160, and the 33 can do 160 also. Their maximum open circuit voltages are 1100 volts. But you'd never want to go that high. You want to stay well under the 1000 volts. In fact, you want to be in the sweet spot, which is around 550 to 550 volts to 850 volts. So yeah, we also have the maximum strings, but we're going to jump down to the calculator. So when we have a look at a module, we will notice that in the module specs, they talk about standard testing conditions and normal operating conditions. Okay, so usually we're going to be looking at this. This is the normal operating conditions are from here. So here we can see these normal operating conditions are the specs of the inverter. I mean, the specs of the module. And so we are looking at a 550 watts module, 72 cell. And that 555 watt module is rated under standard testing conditions, but under normal operating conditions, the maximum power on the wattage is actually 413 watts. When we have a look at the open circuit voltage, it is 46 volts. But if we have a look at the standard testing conditions, open circuit voltage, we're looking at 49. So there's 3 volts difference between standard testing conditions and normal operating conditions. So maybe I can give you a little bit of an explanation about standard testing conditions. I used to work for Solar Direct. We used to manufacture modules. We were the first company in Africa to manufacture modules. We buy in certain raw products from China, and then we make the modules in Belleville, and we would ship, because we were a French company, we would ship them to France, and then the EU said that China cannot use South Africa as a stepping stone, even though we were making our own modules. It was a massive plant. We had everything in place. We were doing everything. All we were doing is just buying in the wafers. Furthermore, and maybe backing sheets and things like that from China, but we were manufacturing our own modules. Coming back to how we would test the modules, so we would flash test them, and that's how we come up to the standard testing conditions. So what that is, we have this dark room, we put the module on a table, and then we flash test it with 1000 watts of sunlight per square meter. And then we get a reading, and that reading would normally be over, maybe like 2 or 3% over the rating of the module. So if you tested a module that is brand new, like a 550, you will probably get maybe 560 out of that module in the first year. So usually modules are, their actual power is a little bit over than the actual rating, and that's not for every module. You might get 1 or 2 modules that will actually go to that 550, but on average, most of those modules should actually give you like 558, 560 under the flash test. Okay, but now when you design your system, you want to design it under standard testing conditions. And the reason for that is because You want to use these values because this is the biggest potential or the most potential to which the system or the module can actually have or can achieve. This is its potential under the right conditions. Now remember, the right conditions are going to be that module at 25 degrees, and at 25 degrees it will give you this at 1000 watts per square meter. Now there can be some instances where that module actually becomes -5 degrees, -5 degrees, and that happens. So if we have a look at maybe the Northern Cape, where it gets very, very cold, and at night your pipes can freeze up with all the water, and that night was very, very cold. Those modules could be at a -6 degrees, and all of a sudden you get that intense sun where you know, okay, well, today's going to be one of those hot days, and that module, because it's got no resistance in the module itself, and the cables leading to the inverter are also very cold, and now that resistance is extremely low, you can transgress, or you can achieve an over voltage. If you achieve an over voltage on your system, you can damage the inverter. So when you design your strings, you want to be using the standard testing conditions to understand what is the worst case scenario if I over voltage on my strings, that I don't want to damage my inverter. So I need to bear in mind the standard testing conditions when I'm designing a system. But when I'm having a look at what is my basic output, and how I'm going to do my payback as to what is the module can actually achieve on a daily basis under most conditions, then I'll look at normal operating conditions. So this I'll use for my payback, but this I'm going to use for how I'm going to design my system so that I don't achieve that over voltage on my inverter, and I damage the IGBTs or my DC bus bar, and I over voltage here. So yes, we can go to 1100 volts. We want to design the system where our strings are not over 850, because anything over 850 is over the sweet spot of the MPPT. All right. We might want to have that over voltage in winter, or a higher voltage in winter, or to accommodate for winter, but usually we're going to want to keep to that 850 volts. So if we have a look here, we're looking at some string design. We're using this module, 550 watt module. At a later stage, they're actually busy working on it now. This will be a drop-down list, and you'll be able to select a variety of modules to complete this calculator here below. All right. So here we're having a look at our string designs here below. We have them at normal operating conditions, which is 1:1. We want to keep within the, this system is designed for the amount of strings in a string, using every single one of the inputs and using all the MPPTs, and still achieving the rating of the inverter. In other words, yeah, we have the 125 CX. With a certain amount of modules, we'll be able to get it to 128 kilowatts on the DC side. If we go all the way here to the end, you follow my cruiser, we're looking at modules in series using every single input and every single MPPT. There's 13 modules in a string, and at 13 modules in a string, our standard testing condition voltage is going to be 646. So that's between 550 and 850. So that's in the sweet spot under standard testing conditions. And under normal operating conditions, we're dropping down by 36 volts. And that's still within the sweet spot of the MPPT. All right. If we look at the 110 kilowatts, we want to have more or less 110 kilowatts on the DC side. We can achieve that at 111 kilowatts, and we will be using 15 modules in a string, 15 modules, and using all MPPT. So that's going to be 18 strings, because we've got 2 inputs into 9 MPPTs. And here we can see that the normal standard testing condition voltage is 745. So yes, we're below 1,100, but we're still within the sweet spot of the MPPT, which is 550 to 850. And under normal operating conditions, we're dropping down by, say, 42 volts. And that's still within the sweet spot of the MPPT. We have a look at the 50 kilowatts. It has 10 strings, 5 MPPTs, and we can achieve 53 kilowatts by using also 13 strings, 13 modules in a string. And there our voltage, normal standard testing condition voltage is 646. So that's still in the sweet spot and well below the 1,000. And normal operating conditions, if we test that open circuit voltage, we are going to get 610 volts. Okay, and then with the 33, which has got 6 strings or 3 MPPTs, we can get 34 kilowatts by using 14 modules in a string. And yeah, we can also see the standard testing condition voltage is going to be 696. And in normal operating conditions, 657 volts. So we're still within the MPPT sweet spot, and we're well below the 1,100 volts. So in the event that we get an overvoltage, or we get those perfect conditions where the module is super cold, the cabling is super cold, there's almost no resistance, and that sun comes up to be intense, we're not going to burn out anything on the inverter. All right. Does that explain a little bit more, Dean?
Yeah, that was amazing. Thank you very much for that clarity. I think it added tremendous value. It reminded me of a lot, and I really truly appreciate it. Ian, thanks for your time. We really do appreciate it. Thank you.
Awesome. Thanks, Dean. All right, so if there's no more questions, then we are going to end the training. If there are any questions, guys, please feel free to reach out. If you need any support or any help, yeah, please reach out. We're always happy to help you.
Cool. Thanks, Ian.